Attimi un secondo, non vedo la cosa di registrare. Registra nel cloud, registra sul computer. Ok.
Well, welcome to everybody. Welcome to all the participants that join us this workshop organized within the Framework Partnership Agreement on Copernicus user uptake, and having as subject the systems and tools for locating bloom of jellyfish and predicting the displacement towards the coast. ISPRA decided together with other colleagues of University of Malta, CMCC, and Stazione Zoologica Anton Dohr to organize this workshop, this event, having as a leading actor the beautiful world of jellyfish, because due to multiple factors as climate change, marine pollution, and overfishing of jellyfish predators, jellyfish population is recently increasing very fast. I want to thank you all the relators that agreed to attend the workshop, sharing with us their expertise on macrozooplankton, but also remote sensing and models. The workshop is divided in two sections. After a welcome from Nico Bonora, responsible for ISPRA of the initiative to support national and European space policies for the implementation of operational environmental monitoring services, we will have two sessions. The first one concerns the methods for jellyfish detection, while the second part concerns the method for study, the dispersion, and the forecasting of jellyfish blooms. For relators, some detail. Each presentation will take 15 minutes. This time includes also questions from the audience. And finally, there will be a general discussion to sum up the proposed experience and propose a new strategy and research way to explore. So thank you, and please, Nico.
Thank you very much, Arianna, for your introduction. Good morning to everybody. And it's a pleasure and an honor to participate opening to this event that presents system and tool for the locating of jellyfish bloom and predicting their displacement over the coast, and they provide information about various monitoring approaches. And as Arianna underlined, illustrates different applications related to Earth observation, in situ identification, even related to citizen science, and also related to the drift forecast of jellyfish. So this is just a brief intervention to underline that this event was developed in the frame of the European program, Caroline Herschel Framework Partnership Agreement on Copernicus User Uptake, FPCAP for the most. That is a communitarian instrument for the uptake of Copernicus service and products to derive downstream service and application to meet the monitoring needs at national, regional, and local scale, both for public and private users. Then we are therefore talking about the fourth Copernicus pillar, I mean the products uptake. The other three pillars, I'm sure you know, but just a refresh, related to the space component, which provides imagery, the service component, which provides monitoring products on an European and sometimes at a sub-European scale, and the in-situ component. And the uptake component is considered equally important at Copernicus level as the other three pillars, because without the uptake, the product's release at European scale would lose its value, their value, apologies. So the FPCAP program that is going to end, this is the last year of funding. It finances three types of action with the scope of train and inform, to build an active dialogue with the users, to collect the user needs and provide guidance for the user-driven development of Copernicus, because I remind Copernicus is a user-driven program, and also to develop monitoring tools and forecasting model. So this event is quite horizontal with respect to the three verticality identified by the FPCAP program, as it presents the state-of-the-art of application, model, and collect the user requirements related the monitoring of jellyfish, and also with the capacity to provide information and tools, not only for the environmental point of view, but also for cross-cutting sectors such as the tourism and safety. So let me thank again for allowing me to take part of the introduction of this event. I wish all the speakers good work and to the participant the opportunity to capitalize on what will be discussed today. So thanks again.
Thank you very much, Nico. So we start with the first session that I said before concerned the method for jellyfish detection. So I start sharing my screen. Can you see the screen? Okay, perfect. Why? Well, I'm introducing an idea that we had maybe 2 or 3 years ago, and we decided to explore the potentiality of remote sensing in identifying jellyfish bloom. And why we have to searching for jellyfish on the sea? Obviously, up to a certain number of jellyfish, jellyfish have a positive impact on the ecosystem because as they support carbon capture, for example, from the atmosphere, transporting organic particles in the depth of the oceans. But when the increase is exceptional, as in this beautiful photo showed, and this beautiful photo made from the University of Malta during their citizen science campaign. So when there is an exceptional increase, this can cause severe problems, mostly when they come in contact with the human activities. And for example, for fisheries, the gelatinous masses can block up fishing nets. Moreover, for swimmers, they can cause a rash, severe pain, rash on the skin. In some region of the world, jellyfish blooms impose considerable socio-economic impact, hardship to the net-based fisheries, aquaculture, power generation, and tourism. I will not go deeper as other relators are more expert than me. So I go on. I start with our idea, to show our idea. The idea to use remote sensing data to find jellyfish blooms on the sea. So this study aims to explore the potential of remote sensing, in particular of satellite of synthetic aperture radar, the SAR is an acronym, to detect jellyfish blooms. Which is the advantages? The advantages is that SAR obtains high resolution remote sensing synoptic images covering broad marine domains, and it can be used day and night under all weather conditions. The idea is that the detection is based on the damped radar return produced by the biogenic surface leak produced by the presence of plants, animals in the ocean, or also by oil leak, for example. So jellyfish blooms dump the water surface by smoothing it, by generating a high specular reflection and lower decibel reflectance values in the bloom area. The detection of blooms through SAR images we think that could be also useful as input for advection dispersion models coupled with the oceanographics model in order to forecast its displacement. But what is SAR? SAR is an active sensor. Active means that produce its own energy and then the sensor records the amount of that energy reflected back after interacting with the Earth's surface. Which kind of energy the sensor transmits? In this case, SAR transmits microwave. We are in this part of the electromagnetic spectrum, and the sensor transmits a wave with this frequency. So the SAR transmits microwave signals and receive back the signals that are returned or backscattered is the term used in the remote sensing field from the Earth's surface. Unlike optical sensor, synthetic aperture radar can see through darkness, can see through clouds and rain. And it has been used in a wide range of applications from study, for example, Antarctic iceberg, tracking the path of oil spill, and many other applications. As a very well-known SAR is the mission Sentinel-1 that is part of the Copernicus space component and is implemented through a constellation of 2 satellites, Sentinel-1A and Sentinel-1B, each carrying an imaging C-band SAR instrument, and that provide in continuity data, in continuity with the previous mission as Envisat and ERS, and Sentinel-1 satellite fly in a near polar orbit at 693 kilometers of altitude. A single Sentinel-1 satellite is able to map the global landmass once every 12 days. The two satellites together, Sentinel-1 and Sentinel-B, are able to map the global Earth on 6 days. Okay. What are the main use of Sentinel-1 and B mission? The Sentinel-1 mission is specifically designed to acquire and provide routinely data and information of ocean, land, and emergency. These services focus on the observation of the marine environment, including oil spill detection and Arctic and Antarctic sea ice monitoring, the surveillance of maritime transport zone, as well as the mapping of land surfaces, including vegetation cover, and mapping in support of crisis situations such as natural disasters. Sentinel-1 has 4 operational modes. In this case, in this study, we use the second one, the interferometric twice-watt mode. That is the main acquisition mode for over land and satisfied the majority of service requirements. It acquires data with a 250 kilometers watt. This is the SWAT. And with a spatial resolution of 5 for 20 by 20 meters. The other operational mode are used for their wide SWAT, for example, in this case, the EWV, in this case too, but the strip map mode is used only in case of emergency. The wave mode is used to retrieve information about waves and wind. So in this case, we used the interferometric twice-watt mode. Well, the first information from which we started was the sightings of jellyfish blooms in the Mediterranean Sea that have been acquired using data from Citizen Science Project. as in this case, we used the spot the jellyfish data furnished by University of Malta. The jellyfish bloom sightings dataset are very well supplemented with metadata, including information about geographic position, species, and abundance. In this case, during the first 2 weeks of June 2016, an intense bloom of Pelagia noctiluca was identified along all the Maltese coast. And the bloom we are going to investigate was identified the 11th June of the same year offshore in the code zone 14 in the yellow, indicated in the yellow circle, according code zone that is in accord to the spot the jellyfish code zone classification. So we extracted from the scientific data hub of ESA the granule corresponding to the same date. So we have the granule corresponding to the 11th June 2016. And these images was analyzed using SNAP software, software developed by ESA. We focused the image on the southeastern area of the Maltese coast. From the inspection of the image, we found a dark area in correspondence of the area where the jellyfish bloom has been detected. It is shown in this yellow circle. In this area, the decibel values, the values of reflectance registered from the sensor, from the SAR, the Sentinel-1 SAR satellite, range from 16 to 18 value. And it is quite different from the rest of the area where the values range from 20 up to 28. So we acquired an archive imagery with not jellyfish observation with very calm sea corresponding to 18th May of the same year in order to compare the two images. The following this slide show the steps that have been applied to both images using the SNAP software. These steps we used this step on both images, the one of June and the one of May. The first 3 steps are necessary to prepare the last one step. So the calibration, multi-looking, and ellipsoid correction are used to prepare the 2 images at the last operation, the band math operation. These steps, in these steps, we perform the difference in decibel, the difference of decibel of the 2 images, the images of May and the images of June. Here, we perform the difference and we select a threshold, this T, that is a value which is the greater than the difference decibel between the 2 images over the dark area, but less than the difference where there is no jellyfish. So we obtained a mask of 0 and 1, where 1 represents a significant difference in decibel, as in this case, is a difference in terms of reflection due to the presence of jellyfish. The other black dots indicate the absence of jellyfish in this case. And as final steps, inside SNAP was implemented the oil spill detection tool. There is a tool inside SNAP to detect, for example, vessel or spill. We use this tool on this image, and we have tried to see what the tool said about this dark zone, this dark area. So we apply to the initial image the tool, and the tool identifies this white spot, this one, as possible oil spill. In general, the backscatter of the SAR, of the satellite signal over the ocean, is mainly a result of sea roughness, for example, short gravity or capillarity waves. But when there is an oil spill, the oil film decreases the sea surface roughness and then the backscatter. So this causes that spills appear darker in SAR images than the spill-free areas. But also other phenomenon that oil spill can cause darker zone on SAR images. And we call this look alike. We call this area that are dark but are not oil spill look alike. And this area can cause false hallmark detections. This film on the surface dump the short wave and create dark patches areas on the surface of the sea. And so we have problem to distinguish between oil spill and what oil spill is not. And look alike, what we call look alike, are caused by, for example, natural film slicks, grease ice, areas with specific wind speed, or rain cells, internal wave, algal bloom, and also jellyfish bloom. And it is these two figures, the comparison of these two figures is the demonstration, because the study confirms the possibility to detect jellyfish blooms from SAR images. We have this area that is the same of this area detected from the oil spill detection tool of SNAP, and this is the area detected from our investigation. So the study confirmed the possibility to detect jellyfish bloom using SAR images, exploiting the effect on the water surface produced by the gelatinous zooplankton. So this result confirmed that the effect is the same. The effect produced by an oil slick is the same or that one produced by the jellyfish blooms. In this case, we are facing a problem of look alike produced by the bloom. Well, the detection of jellyfish bloom in the open sea, we think that could be connected to the availability of operational oceanographic model, because this could lead to the possibility to build up an early warning system. And in the second part, we will talk about this with the other two presentations, in order to identify the coastal areas that will be hit by the bloom in the following days. What do we want to do in the future? In the future, we would like to characterize the jellyfish sighting area to physical parameters, such as, for instance, temperature and current and speed direction, in order to highlight possible patterns useful to characterize the presence of jellyfish, the characteristics of the bloom, jellyfish bloom, and their displacement. Work are in progress. In this case, for example, the distribution of temperature and wind current, speed and direction of shore Malta on the date of the sighting of June, the event we have seen before in the images before. The data comes from the reanalysis available at the Copernicus Marine Service, CIMENS. So to conclude, also to speak about perspective, the effect on the water surface produced by the jellyfish, by the gelatinous zooplankton, is the stain produced by a noise leak. And we are facing with a problem, with a phenomenon of look-like produced by the bloom. An effort still needs to be made, to discriminate between jellyfish blooms and olive spill. The contribution of information about related physical parameters, for example, current, spinning direction, sea temperature, in the detection of jellyfish bloom, have to be investigated. We want to investigate in the near future the contribution of physical parameters. And in the detection of jellyfish blooms in the open sea, connected, as I said before, to the availability of operational oceanographic model, could give the possibility to construct, to build up an early warning system to identify coastal areas that are interested by the presence of jellyfish bloom. And that's all. I hope to be sure. I don't know if there are questions. Okay. Questions or doubts or consideration?
I have one question.
Right.
Svetlana Lyubartseva is speaking from CMCC. Could you see jellyfish on optics images?
There are several studies about the detection of jellyfish from ocean colors images. They are obtained quite good results, but the problem is that images have to be cloud-free. Yeah. Vice versa, the SAR images are not affected by the darkness. They see through darkness, through clouds, through rain cell. So yes, the difference that they can observe in all weather conditions.
But using optics, you can definitely distinguish jellyfish from oil spills.
Yes, in general, yes. There is in some occasion we know that EMSA alerted. The EMSA is the European system that alerts for oil spill, that alerted for an oil spill, but when the Capitaneria di Porto, I say when the when the Sea Guardian went on the place, they found a very large bloom of Velella. So also from optical sensor, there is the possibility to have a look-alike when there is a warning for an oil spill.
And second question, we know that SAR images, SAR imagery is also not perfect because there is limitation connected with wind speed. For example, there is optimal corridor of wind speed for detection of oil spill from about 2 to 10 meters per second. Is there the corridor like this for jellyfish?
Also, wind speed affect the quality of SAR images, yes. But in general, when I found I try to use a very calm day when we don't have strong wind sea, and when we have a very calm situation, no waves, no wind speed, or not so high, so the detection is easier because we don't have more phenomenon that sum up on the same, or could sum up on the same image.
This is absolutely different from a detection of oil spills, because without wind, we have dark spots, and these dark spots can be confused with sea surface oil spills.
Yes, but we have a chance. We have a fortune because we start from the sightings. We start from the notice, the fact that we have sightings, and we know that in this case we have jellyfish.
Yes.
We start from in situ data.
Yes, thank you very much. Thank you.
You're welcome. So thank you for questions and for your time. And then we goes on with Malta, with Alan Deidun of the University of Malta. That I want to.
Please, there is Valentina that have a question, I think.
It was
sorry.
Just a very short comment. Very nice study. Did you take in account to test your methodology also with different species of jelly? Because when I saw your data, I was thinking about that the density of pelagia, for example, is very different from the density of Rhizostoma pulmo. No. I suggest you to test this because, okay, I have not the way to use your very high qualified method, but when I look the presence of Rhizostoma pulmo from drone images, they are so big and so dense that probably they can give you a very, very good result. So I suggest you to test it.
Okay. Thank you, Valentina. We have started from pelagia, in some cases also with velella, because they swim on the surface.
But velella is a film. Velella is a film. What I'm suggesting you is to try with something easier.
Easier
to show that it works, and after to came to something that more difficult.
Okay, we will try, but we need to start from sightings, from in situ data. So if you have sightings data about rhizostoma, bloom rhizostoma, please share with us, and we will try also with.
No problem, you will see.
Okay, thank you. So goes on with Alan Deidun of University of Malta. That I want thank you very, very, very much, because the data of University of Malta was the input of our study, of our idea. So Alan, we will talk about the experience of Spot the Jellyfish campaign, and please, Alan.
So yes, thank you, Arianna. Good morning, everybody. So in fact, I had a small question, but I think it has mainly been asked. It has mainly been answered in your reply to Valentina, because I was going to ask about the depth at the surface, because I think obviously from satellites you can only detect surface blooms, but if there's species obviously which are capable of vertical, excursions, let's call them like that, vertical excursions in the water column, they wouldn't be detected. So probably we're looking at a set of species, possibly pelagia, possibly Cotyloryza, possibly velella, and the surface species, So that's what I wanted to ask. So I can share my screen, I think. Yes.
Yes.
Okay. So just to before I start my my presentation, I just wanted to show you, if I manage, just a second, and let me know if you can see. Can you see my screen?
Yes.
So this was published actually today on a university, on a local newspaper site. So this is from today, 15 June 2022. And I'm sharing it just to let you know that how interesting this topic is for the general public. So I think since we've been bombarded with requests, and probably it's the same for most of you, from the media, to give information and to give insight on what's happening. I think since last March, so we've done many interviews, because this year has been a particularly bad year, let's call it a bad year, in terms of pelagia blooming here in Malta. So we've had a very long, an enormously long season with pelagia blooming. And our obviously this requires further study, but a possible cause for this might be the drop in sea temperature that we've seen this spring. So in our waters, we've seen that sea temperature went down quite a lot for the first time since 5-6 years, and it was cold for a long period of time and late till it was cold till end of April. You know, normally in the Mediterranean we speak of and I'll stop sharing so that I can start my presentation. Normally we speak of the February minimum in the Mediterranean because from March the sea temperature starts recovering, but it was going down till the end of March. So this obviously might have had an impact on the development of pelagia, on its annual spawning, you know, which we normally see in January, February. And something else, I'm sorry if I'm sharing these observations, you know, but it's good to have the community of jellyfish people online at the moment, so it doesn't happen every day, because it's good to get these, to see what's happening in your part of the world as well. We didn't get Velella this year, so we almost totally missed Velella. I have to check the database, but so far I haven't seen any reports, whilst we've had massive blooms of Velella in the past 2-3 years, I would say, you know. So, but this year, for some reason, we've missed completely Velella. So I don't know. Again, it's been a very strange year, you know. But anyway, so let me share my screen again. So I go on the presentation. Okay, I hope you can see my presentation. Okay, so let me go in presentation mode. Okay, so yes, I'll be basically showing you a bit. So it's not a very scientific presentation, because I'll be speaking mainly about the citizen science efforts that we have been doing in Spot the Jellyfish over the years. Okay, so basically we have a variety of ways through which we communicate with the public. Okay, so we have the website, we have the social media pages, we have smartphone apps, and we even have seaside panels. Okay, so which I think are very visible, very popular. Okay, to obviously tell people about the campaign and to urge them to send the reports. Okay, so we've even we regularly host events and activities with kids, you know, and activities like this, you know, drawing competitions and so on. Okay, because the challenge, and I think Dori and Valentina and perhaps Serena and other people who are very familiar with citizen science campaigns, the challenge with these sort of campaigns, which have been going for a long period of time, you know, we started Spot the Jellyfish in 2010, is to keep people interested, you know. So it's not that easy to keep people interested after so many years, you know. So people would say, why on earth should I send you my reports? I've already sent you a report last year or last month. Yeah, so people tend to send reports when it's a new phenomenon, when it's a new species. We see this a lot with the Spot the Alien and the Spot the Alien Fish Citizen Science campaign. You know, if something has already been reported for Malta, they don't see the point in sending you the reports. So this is, I think, a big challenge for citizen science campaign, to explain to people that we need the data for monitoring and for identification of trends, not just to spot new species for the new records, because there's the misconception out there that citizen science campaigns are there simply to get the new species, you know, as an early warning system. Okay, that's an element, but citizen science campaigns are not there only as an early warning system. Okay, for the new, for example, we're all waiting for the lionfish. When I say we are all, obviously Dori will be smiling here because they're full of lionfish, but we are expecting the lionfish anytime soon, because from literature we know that it's been spotted in Tunisia and in Puglia, in the Ionian, you know, in Albania, and so Malta somewhere in between. So that is the early warning system. But still, any other species that we already have here, we want to monitor them. Okay, and we do documentaries on jellyfish, something that is very useful, I found to be quite useful, is not just underwater documentaries, but animation clips. So these sort of short cartoons. And perhaps at the end of this presentation, I can switch on to YouTube and show you our short animation clip cartoon on jellyfish. It's just 1 minute long, you know. And we normally, when we're speaking about jellyfish, we start off with this cartoon because it really sets the context on what jellyfish, why we're interested in jellyfish, and blah blah blah, you know. But this sort of interaction is important, especially on a small island like Malta, where when you have an event like this, which is live streamed on Facebook, you get such a big following. So we tend to do a lot of these events at the aquarium, at the Malta National Aquarium, and they're followed by, I would say, at least many hundreds of people, but sometimes even thousands of people on Facebook. So, and this is good because it gets coverage and you get the report. So I would say 80%, 90% of all the reports of jellyfish in Malta come to our campaign, okay, which is good. So, and this is all obviously in line with the United Nations Decade on Ocean Sciences, obviously 2021-2030, where ocean literacy and citizen science is a very important tool for ocean literacy. Ocean literacy plays a very important role, okay? So yes, as I said, we started in 2010, so in 2020 we turned 10, okay? I'm skimming through some of these things. Yes, here I see Serena, obviously, and I'm not sure if there's any of the other co-authors here. I think not. So some of the data we've collected over the years in Spot the Jellyfish has obviously contributed to a regional exercise, a regional, I would say, research effort to actually come up with probabilistic models, obviously in the form of species distribution models, to try to forecast the presence of jellyfish blooms, so try to predict future blooms. So this was an exercise conducted within the MedJellyfish project, about which I will be speaking briefly once again. And why am I making this reference to MedJellyfish? Because I obviously want, and I think it's the objective of many of us, including Dory, for example, you know, that we go for a future project together once again. I think there's a big need to have a new project now, you know, where we're all collaborating together, perhaps even with other partners as well. Why not, you know, where we don't lose the momentum on jellyfish research in the Mediterranean. There's recently been Go Jelly, obviously, funded at EU level, but I think we need a Mediterranean project now. So through any CBC Med, you know, through that instrument, through Interreg Med, I don't know, I think these two instruments might be some of the best instruments, perhaps not the only ones, but they are some of the best because they have obviously a Mediterranean dimension, okay? So let's keep our eyes and ears open for future opportunities. And obviously Interreg Med, I haven't heard much from any CBC Med recently, but I think Interreg Med, there's been the first call, which was on governance. Probably there will be the new calls for Interreg Med, which we might explore, okay? So again, as I said, this was an exercise, this published in Diversity, whereby we combine data from citizen science from Italy, Spain, Tunisia, and Malta. Okay, and we came up with these with this probabilistic model, you know, with these forecasts for through ensemble modeling, through a variety of probabilistic models through R, through the language R, for these four regions. Okay, and we combine them obviously with observations from citizen science as well to see how these were performing. Okay, and we had over the years other publications where we made use of the data from Spot the Jellyfish. This was another small publication, I would say, published in the Journal of Coastal Research, where we used data till 2015 and we regressed this with a number of water column parameters, mainly derived from satellites, again, like SST, you know, salinity, chlorophyll, and so on and so forth, you know, to try to identify patterns for the major species found in Maltese waters. I think we did this for Pelagia, for Cotyloryza, for Velella, salps, and comb jellies. Okay, and again, besides the I would say the quantitative sort of studies, okay, the trends and so on, also the qualitative ones where we identified new species occurring in Maltese waters, things that we didn't know about, which I think were already here but went underreported. For example, the porpita, okay, the blue button, porpita, bottom right, down here. I think porpita was here already before spotted jellyfish started, but I think it went underreported. Okay, so that is again another advantage of citizen science, that obviously it's not only to report the aliens or the new arrivals, but to actually report fully what you already have in your waters, you know. Actually, the first report of porpita from Malta, it was by a French girl, a 12-year-old French girl who was on holiday in Malta, you know. So, but then we had new records, which I think these were real new records, like Philorhiza punctata, the Australian spotted jellyfish. We had other indigenous species like Chrysaura, Hyosella, okay, the compass jellyfish, which is obviously indigenous. But then we had Ropilem, and the Ropilena from Malta is an interesting case because it was filmed by a diver for the first time. Prior to the start of spotted jellyfish, he forgot all about those videos. And then when he heard that we started spotted jellyfish, he showed the videos, you know, and
Alan,
we identified it. Yes?
Alan, you have more or less 2-3 minutes.
Okay, I'll rush through this, okay? And the upside down jellyfish, which is the Cassiopeia, which again has expanded greatly in Malta in recent years, and also a number of siphonophores. Again, these could have already been here prior to spotted jellyfish, but they went underreported. Okay, so has been, especially this year, a bonanza of gelatinous plankton, especially these fine structure like the siphonophores, could be due to the anomalously cold weather we've had in springtime. Okay, so I'll skip through this. Okay, this is a Velella bloom from Malta. I think this was 2014, which I spoke to. So sometimes Velella, when it forms blooms here, they're really massive. And this was from just one location, completely covered the sea, choked embayments, and so on. Okay, so, and the photo that Arianna showed was featured in The Guardian in the UK. Okay, it made a hit. And we had our campaign, Seaside Panels, even featured on Euronews recently. In February, we had Euronews featuring in Euronews Green. So they spoke about our jellyfish campaign. So I think it was good. And these are some of the stuff we're planning for the future, even board games, like Monopoly style, but dealing with jellyfish. And you have the questions for the kids, asking them about the species. So teaching kids about, we liaise a lot with art students here, and they do their projects on spotted jellyfish. So they get to do their projects within their degrees, and we get free artwork. So rather than go to designers, we get the students to actually, and they're really good to design, to get new exciting artwork for our done. This is, I love this slide because it shows you the evolution of seaside panels within the campaign over the years. So before 2010, before we came along, this is what there was on the beaches, really unattractive and uninformative. Then we went for overkill. We had seaside panels, which were, you know, too much information. And then obviously we learned from our mistakes, and this is what we have at the moment. You know, so these are funded by Malta Tourism Authority, by the National Tourism Authorities in Malta. It might sound strange, but we spoke to them and we told them, listen, it's better that we give out an informed opinion so that potential tourists coming to Malta will get the facts right, rather than people searching online and saying, wow, there's a lot of jellyfish in Malta, let's not go there, you know, and so on and so forth. And the last thing, obviously, we are combining now AI My colleague who couldn't be here, Dr. Edim Gauci, who you might know, is an expert in image analysis and machine learning. And we've developed, and this has been published, this is the paper, we have developed an algorithm which identifies through images, and it gives you a probability. So it gives you a probability of what the species identity is. We've tried it on our 5 most common species because you need to train the algorithm, and we had hundreds of photos on these 5 species. That's why we limited it to these 5 species. I hope that in future this algorithm is embedded within our website, within our smartphone app, whatever, so that people get a real-time response. Because people complain that in summer we don't manage to reply to all their requests in time, because we get inundated, obviously, So I will stop there. These are some slides from Jellyfish. I will skim through them because there's Serena, who was obviously part of the core team. This is some of the stuff we did through Jellyfish, which helped us as well for Spot the Jellyfish, obviously. These are postcards. This is really, really popular. The one on the left, the Jellyfish stink treatment booklet, we had to print it 4 or 5 times. And at the end, we put it on our website. We put it on our website so that people could download it from there. Because people ask about it all the time. Okay, and the fact sheet on the right, the app, we have a Jellyfish dispersion model, which still has to be validated. So it's not a forecast model. This is a Jellyfish dispersion, similar to the oil spill model. We are validating it by the use of drifters. Okay, nets, we tried and tested nets as well. Mixed feelings there. We might discuss it later on how these performed, again through the Jellyfish process. Okay, so I'll stop sharing. Sorry for going over time.
No, perfect. Thank you, Alan. Very interesting presentation. And I don't know if there are questions. I have a question. What do you think about the use of mobile phone to share photos, videos, use this on the citizen science campaign?
Good question. No, they are helpful. Everybody's taking his phone everywhere nowadays, and the cameras on mobile phones have really improved. So even myself, I was skeptical, but I'm not using my camera that much now. So because the cameras on phones are really good, I definitely should be used, especially for social media. We get a lot of reports for social media. I have mixed feelings nowadays about smartphone apps. The issue is that you cannot keep up with all the platforms. You cannot keep up with Facebook, with Instagram, with the website, with emails, it's impossible. We do all of this work, and I see Dori agrees with me. We do all of this work voluntarily. I spend at least 2 hours every day replying to people on Facebook. And here in Malta, we're still old school. People still use a lot of Facebook, unfortunately, not Twitter and not so much Instagram. Facebook still dominates here. And people don't go through the website, unfortunately. I think only 5% of our reports go to the website. They go through Facebook and through private messages. And that, for us to input the reports, I have to save all my Facebook messages and put them in and submit the report myself so that it goes in the Excel file. Because then it gets plotted. We plot all the reports on a map of Malta once it's validated. Once it's validated by us, it gets plotted. And sometimes you get a backlog of reports which still need validation. So they're still not on the map, and people call you, why my report, I cannot see it on the map, blah, blah, blah. So it's a headache. So I wouldn't add a lot of platforms, because if you don't have the manpower or woman power, obviously, human resources. If you don't have human resources, forget about going for multiple platforms, because you would be shooting yourself in the foot, so.
May I ask, please?
Yes, of course.
Hi, Ellen.
Hi, Svetlana.
Nice to meet you.
We met in Rome last time. We met in Rome.
Yes.
We met in Rome in Amara.
I adore your activity, your applications. I visited very often your website. It's perfect, I guess. Tell me, please, if you face anytime some errors in working with public. I mean false positives or false negatives.
Very good. Yes, very good point. Very good point. That is obviously one of the, how shall I say, tricky parts about citizen science. We always encourage people to attach a photo with the report. I would say 80–90% of the times it happens. For the minority where there is no report, we use, let's call it expert judgment without being too paternalistic, you know, in the sense that if somebody sends you a report of a Pelagia bloom, of a bloom today, and I know that there is a Pelagia bloom happening at the moment, I accept it. But if somebody sends me a report of 500 Physalis, Portuguese man o' war, and I know that Portuguese man o' war is very rare in Malta, we get it, but not 500 as they get in Spain, we get one-offs, then without a photo, I cannot accept it, so I weed that out, you know? And we remove doubles. So for example, if there's a person at bay 1 and the second person at bay 1 on the same day spotting the same species, one of them has to be removed, because otherwise that skews a bit the data, you know. So but yes, I think we pick up most of the phenomena. It's not like the aliens. Citizen science for alien species is trickier. Jellyfish, I think, were created for citizen science. Jellyfish are perfect for citizen science, you know.
Yeah. Thank you very much.
Thank you. Valentina say that she does the same. She does the same.
I agree completely in everything was the talk about of Alain, and I don't want to take more time. I just say I am with you completely.
Thank you, Valentina. Thank you very much. Thank you.
Maybe also Dari is with you and is the next speaker.
Sorry, Rena, can I just a quick question to Alan, no? Because you were mentioning, yeah, sorry, you were mentioning that now you need a Mediterranean project, and maybe eventually there is something available for you, because I'm going to present a Progetto Mediterranea later on. But just a quick question, how do you sensibilize people and citizens to do this kind of activity? Is there any procedure, any process, or any advertising that you do?
It depends on the, it depends obviously on the, how shall I say, on the target group. So, and the language you use. So first, nowadays we have a lot of digital tools. So the animation, that one minute there, we always take it with us because it's on YouTube. So we just need a Wi-Fi or 4G connection, and we tell them, let's connect, and we see it before we actually start. Then we obviously print a number of freebies that we take with us, like posters, you know, like, now we have caps and t-shirts, you know, and so on and so forth. So, but that's for the, I would say, the general public. But then if you need targeted for a number of stakeholders, obviously you need more scientific arguments, and you show them the data, you know. I use the things from other projects. For example, Go Jelly send me this with the, it's not very, and Doris is familiar with this. This is the cookbook developed within Go Jelly, you know, for jellyfish. So by Michelin starred cooks. And when we go there, you know, and we show this, and we tell them that in Go Jelly they have they're extracting jellyfish mucus to be used as a microplastic and nanoplastic filter. You know, they're like this. So it's not that difficult to sensitize people and to make them, you know, interested in jellyfish. As I said, jellyfish are really an easy group to work with. People are really interested in jellyfish. So for other groups, it's a bit more difficult. Alien species, people don't see the point of reporting alien species. Perhaps the lionfish is the exception. The lionfish, I think the message is coming across that the lionfish is something to be aware of, you know, and we use a lot of examples from the East Mediterranean, you know. So whenever I follow newspapers in Cyprus, in Israel, in Greece, in Turkey, and whenever there's a big done, I post it on my social media, and we say, listen, you know, this might be happening in Malta in a few years' time. So the East is our crystal ball. The East Mediterranean is our crystal ball, you know.
Okay, so basically the idea is just to spread out the message as much as we can to sensibilize and just to increase more and more with data and monitoring. Cool.
You have to be on social media. Unfortunately, you have to be on social media all the time.
Yeah.
All the time. So I try to post something 2-3 times a week at least, you know, because otherwise you start losing interest, you know. So it cannot, you just need 15 minutes or 20 minutes, because as you have a list of social media groups which are imported in your country. For example, Malta National Aquarium has 130,000 followers. So I post the same, you know, article, the same text in multiple groups, 10, 15 groups, diving groups, snorkeling groups, whatever, and you easily reach half of the population here in Malta in 20 minutes. So you need to be you need to be geared like that, you know. So
okay, thank you very much.
Welcome.
Yeah, thank you, Alan.
Thank you, Dori.
These are echoes of shades of what's going on in the Eastern Mediterranean and all over the place. I think mainly the northern part, but we'll see more when I present. No.
Yes.
Okay, allora let's go on. Dori, please. Dori had a list of from the University of Haifa. Could you show your presentation about your experience of blooms in the Mediterranean via the identification of blooms via citizen science?
Right. Can you see the screen?
Yes.
All right. So we will be speaking more about hindcasting than forecasting, but we want to go there in the future. And by working with citizen science, this is part of a think globally and act locally kind of thing. And we have come to the conclusion in the Iliad project by the EU that looks at the digital twin of the ocean. That means that we want to get an on-screen representation of what's going on in real life. And also we want a process behind it. It's not just displaying the world on your screen, it's also interacting with it and with you as both when you are a citizen, for example, in citizen science, you are both a provider of data and you are our client, you're our end users. You are who we want eventually to benefit from this. So in Iliad, we have come to the conclusion that in order to get a good representation on screen of what's going on at sea, we need everyone on board. We want all of the initiatives, and Serena and Tomas will be speaking with us later, are with us, and Alan, of course, is one of our main partners. And I will now show you how we aim to do this. And then later we'll speak a bit about our neck of the woods in the Eastern Mediterranean. So at first, we want to take data from the citizens by the existing initiatives that are working, like ours and Meduse in the Eastern Mediterranean and several others. I'll show you them to you in a minute. And this interaction produces data. And we want to QA this data, make sure that everyone is doing okay with QAing, because it's a lot of work, like Alan mentioned. I myself spent a lot of time going through people's reports and making sure that we validate them. And then we want this data, we want to crunch it. And we want, one thing I want to add, Alan, if you see the word ontology in there, is if you're doing social media, then we have people in Iliad that actually take your feed, your Facebook feed, or they did it with Twitter before, but we can take the Facebook feed and press it into, like, take all of it and exert data from it, actual data, through the use of words. The algorithm, the ontology algorithm, can identify specific words and sort of make sense of them and maybe validate in retrospect your reports, and through that we can map the process in time and space as well. But eventually what we want to do is just take the reports and QA them and create risk maps. And I appreciated when you mentioned this in the context of what the end product is. And I'll show you some of the things that we did in the Eastern Mediterranean in that context. Eventually, that's going to flow through tourism, which is our main, I think, our main market here, because if you look at ecosystem services, jellyfish are the only organism that directly affects all of them. Like cultural ecosystems are the ones hurt the most, provision ecosystems through fisheries and aquaculture, and desalination and energy, of course, and also you know, just the very fact that they're out there and they're impacting the ecosystem itself is a large thing. So if we get really good data and we can maybe try and model it with sea states and currents and all of that, we'll get through modeling and we'll get oceanographic data, and by that we can improve our risk maps. I'm careful not to use the word forecast, because this is something that we will probably be able to do good on a local scale, but not on a pan-Mediterranean scale. So on a pan-Mediterranean scale, this is what we need. We need our partners. I will mention here CIESM, as well as the Med Jelly Risk Project, who have attempted regional approaches in the past and did a fine job of it, but not really to the level of supplying good real-time information. And as for the data, it was different contracting parties in CIESM, in JellyWatch, for example, reported different intensities in different times, and it was really hard to piece together the entire picture. So we are hoping to do something like this, look at where these citizen science initiatives lie, and take the data and sort of what you did regionally in the Western Mediterranean, try and get it going for the entire sea. From Portugal to Turkey, we have partners that we've met with, and we appreciate really the turnout, because it seems like there's a lot of partners in the Mediterranean to work with, and we just need to make sure that we get all the data, because the data is very, very different from the way it's collected. I'll show you right now. I'll show you the way the data is collected, and in order to make this into one, you know, then we need to take sometimes the lowest common denominator, and sometimes you need to actually aim higher and push all of us to do a better job in collecting the data. So we're looking at personal data that is being collected. Every one of those columns is one of the initiatives. I'm not going to show you all of them, and to protect people's privacy, I don't want to publish this online, but we've shared this with our partners as well. You know, we collect the contact details, date, time, location, for example, can be either a pinpoint on your GPS if you have a smartphone app, or it can be like in Malta or in Israel, like regional approach of looking at different places. And that's just the alongshore location, because the offshore location is really, really important. The gelatinous fauna in 1 to 5 kilometers from the beach is very, very different to get in the beach itself or on the beach. So we get that. We look at different activities. Most of the initiatives actually don't ask the people what you do when you're out there. But as we saw with Sentinel-1, and thank you for that beautiful presentation, Ariana, when you look at the sea from above, you see something completely different, and Alan brought it up, than what you see when you look at the sea below. So if I envision someday when machines replace us, and I'm not for that at all, if machines replace us in looking at jellyfish, then we're probably going to be looking at cameras in the water, maybe drones, and maybe satellite will eventually enable us to do this better. But in the water, it's really, really important to look below the surface. So activity is important. We look at the different species. We got like 36 different species, maybe 12 main species that we want to look at. Obviously, the larger and stinging ones, or the ones that are completely overtaking the sea, like Nemiopsis, for example, are maybe main species that we want to focus on. We look at the quantity and density of species, and this is probably the hardest thing to assess, because several initiatives use density, others use quantity, and they use different ranking systems, or sometimes it's a scalar number. So this is probably when where the most thought is going to have to to go into the process, because you can see here many have used the CSM system, which allows you to either use quantity or density, and others have just created their own scales. But everything is scalable. This is all doable, and in the data management process, we will make everything transparent, and hopefully we can share this with you in 2 years' time. We have another one of these workshops, and we will be having a lot of meetings among us. But if you guys hold something like this in 2 years' time or 3 years' time, I'm hoping to be able to come up with what this looks like when we throw it on a map. The size of the species is not always collected. Also, something that we're gonna want to look at, because when a swarm evolves, then typically you can track its path in time and space through looking at the sizes of jellyfish. Not always. Photos that Alan mentioned, the training level of citizens, whether we call them like gold users that are ultimate citizen scientists. And if you asked about motivation, we tend to find that our gold users, the people that are with us the most and want to undergo the process of learning how to identify the jellyfish and how to do surveys and transact and report most often, are senior citizens. They are your perfect citizen scientist is a senior citizen. Not the only ones, of course, and kids are great, and we've been working with kids. Thank you, Alan, for pitching that, because when looking at your photos, I feel like we've been going through the same processes. Me and Professor Dror Angel in the University of Haifa, we've been doing those things that you showed, and it's good that we have to learn from each other. But on the really the bottom line of who reports the most and who reports the most consistently, then we have really high level of senior citizens that have been with us for 10 years now, and they are great. It's of course everyone in the population, and in the summertime you always get spikes of everyone reports, but in the winter season and when it's hard to get reports and it's really important for the modeling part, then you need to have your people that stay with you, that they walk on the beach every day or they swim in the water, and they're your gold users. So the level of training is important to note when you know who is submitting the report. Some of the initiatives have reports that mandate photos. Some of them are just some of them are just people that have been with the process for a while, and some are just walk-ins from the street that have made their first observation in the first day, and then we gotta go through the process of maybe validating in a higher level. So we have the platforms are used, the user uptakes, and next, and you guys know that it's coming. We want to get the data from everyone, the actual observation data, and hopefully with us in the Eastern Mediterranean, we always feel like we're holding one of the feet of the elephant. You know the story about the blind people that are all holding different parts of the elephant, and nobody knows what the entire elephant looks like. So this is, for us, jellyfish blooms in the Mediterranean. It's an elephant, and we are only holding, each of us is holding a separate part. And until we open our eyes or somebody turns on the light and we can see what the entire animal looks like, then we are really dealing with local blooms. So I'm going to tell you now about, real quick, because we don't have much time, about the local bloom that we have that is spreading around the Mediterranean. And as Alan showed, has already reached Malta and even Sicily and Sardinia in the last 3 years. In Tunisia, they're getting blooms of Propylema nomadica in the fall, I think. In Israel, it's in the spring. In the entire Levant, it's in the spring. But we also get a lot of swarms in the winter time, which, like Alan mentioned, there's no pickle in the water, but there's a lot of jellyfish. So here's the story of Propylema nomadica, quick from the Eastern Mediterranean. We're looking at an area that has mostly a longshore current along the shores and several eddies in the open waters. And if we look at what Propylema nomadica looks this morning in Israel through our app, then you can see that it's only this. I downloaded this morning, and Alan said something about cold water this year, maybe because of Honga Tonga, we're not sure. The sea lags by 2 weeks 2.5 weeks after where it's supposed to be. So far as temperature, that's just SST. But jellyfish are already here. You can see them in the south of Israel, and that's by no chance. They just got here. This is from the last couple of days, the reports, and still all the north of Israel is jellyfish free, and that means that there's south to north motion with the currents. Now, there's not only Ropilema nomadica in there. Now, Ropilema nomadica in the top you can see is present almost year-round. Mostly in the late spring, early summer phase, but along with Ropilema nomadica in that phase, we can get a lot of other species. Rhizostoma pulma that you know, of course, from the Western Med, and Phylorhiza, Cotylarhiza, Aurelia, and Marivagia. These are all species that we see co-occurring with Ropilema blooms. So there is something there that is not just monospecifically good for one species, but for all the species. Who doesn't play by these rules? That's right. Nemiopsis lady is, we see them all year round now. So you have on the y-axis the year, on the x-axis the weeks, and you can see all year round we get Nemiopsis. And Pelagia, of course, we only get them in the winter time when there's strong storms that push them towards the beach. And that is why, because they are horoplanktonic, and Ropilema are metagenic. In fact, they have a polyp stage like Rhizostoma on the that sits on the bottom of the ocean, and that makes a huge difference between how you monitor Pelagia and how you monitor Ropilema in Rhizostoma. Because in the case of Ropilema and Rhizostoma, there is an importance to the location of polyp beds. Right. Regarding Nemiopsis, I'll take 9 more seconds of your time to show you this amazing GIF. That's my favorite GIF of all times, and that is Beroi, which is a different non-indigenous ctenophore that got here right after Nemiopsis got here, and it eats it and then regulates it. And you can see this in the waters across from the Israeli shores right now if you have really good eyes and you go out there and look for plankton. And it's an example of the potential maybe of biological warfare, which might be our last resort against jellyfish. But even beyond that, maybe our realistic resort is to learn about them and to teach about them and to understand them, to map them, to do exactly what we're doing here today, is to track them and understand the patterns, right? So in Medusa Bam, in our website and an app, we've been active for about a decade, and you know, most of us who are in this have been active for about a decade. Most of the initiatives some of them are new, some of them in the last 5 years, but most of us, that's when we really got started. And what we've seen in this decade is really that we know the patterns. We can do something like this for almost every species in almost every place where you have a good citizen science project running. You can see the months on the y-axis and the year on the x-axis. This is out of a previous publication, and we are able to do this for almost every species. I think now, if there is a good citizen science program running, we can get a good temporal picture of what this looks like. If you monitor the sizes, you can also, sorry?
Sorry, 2 or 3 minutes also for you.
2-3 minutes, okay. So what we did here in this study was we took 2 beaches, 2 bathing seasons, and looked at the very strong interannual differences. You see in 2017 we had in the red colors, in yellow we had a very strong Ropilema bloom and longer one, and in 2018 the colder colors we had for some reason we had almost no jellyfish in the spring and very little jellyfish later in the fall. Very strong interannual differences. So we know the averages, but what makes for the actual annual, let's say, makeshift of the swarm. So one more thing we did in this project, we looked at the genetics of Ropilema nomadica, and similar to other studies that have already been done, we are talking about a single population of one, let's say, unstructured population across the entire Eastern Basin. So we do need to get jellyfish from Tunisia as well, or from other places to make sure that this is still the case. But we are talking about one giant population. And if we want to look at a specific beach and understand what impacts the swarm in it, then you've got to start with your currents, what brings the jellyfish there. And since they are metagenic, we want to understand where the polyp fields are. So we looked at the current models. This is Simon model with Norwegian Sintef partners, and we looked at the drift time, and eventually ended up with maps that traced the origin of Israeli swarms to the Egyptian Nile. Of course, if you release the jellyfish from polyp beds in Israel, for example, then you would be getting a swarm in Turkey later. And of course, the blooms in Sardinia, they are fed by other currents. But we do know that in the Nile area, there is a lot of nutrients, and it's a good place for polyps to sit, and for maybe for the ephirae to grow. So we get them about 300 kilometers to the east, and about 3 months later, and that's the time it takes them to grow from ephira to juveniles. And you can see the patterns that take them not only to the beaches, but also ephirae, for sure, we know this, are going into the gyres in offshore waters. And this is important for monitoring purposes, because sometimes only the longshore current can't explain everything. And sometimes we get in the winter, for example, we get really stronger west to east gradient of waves and winds and currents. And sometimes we get huge swarms in the winter time as well. Right, so the polyp beds are probably near shore, as we saw in the previous slide, but the transport is many times it's offshore. And right now, if we remember the photo that I looked of our website and what it looks like today, we get them mostly 1 kilometer, 4 kilometers, 5 kilometers offshore, but the beaches are still clean. You can go to every beach in Israel right now and bathe, and in 1 week time, they will be starting to hit the beaches when the currents pick up. So offshore transport. Really, thank you for your attention. I don't want to take too much time of discussion time, and we are behind schedule. As a take-home message, Ropilema is coming. Alan called it the crystal ball. You can definitely see it spreading more and more westwards in Western Mediterranean, and probably it will spread north as well with climate change. And my second message is that if you want to use citizens, which are great sensors, we have amazing capabilities, then there is a huge importance to the local initiatives that are already existing. One day, Google, like Google Lens, for example, that does what Alan is trying to do with image recognition, or if you know iNaturalist, they are one day someone bigger than us, than all of us, like Google, or Elon Musk, if he decides to, will come over here and just overtake the whole thing. But as we saw, even satellites still they grapple with the difficulty of really understanding jellyfish swarms. So what we need to do is, until that day comes, and that could be a decade, it could be a century. Technology, we never know. It works in like leaps and jumps, and we will be there to support it. Until that day comes, I think the human eye is an awesome sensor. And since humans are our end clients in the end, then we want to interact with them. We want the back and forth. And for that, we must have the local initiatives. Thank you once again for your attention. I'm open to questions.
Thank you to you, Dori. Very interesting presentation. A lot of things, it's very a multidisciplinary presentation, a lot of experience inside. Someone has have a questions? I have one. Dori, who are the potential users of this in-casting model for you?
Okay, that is the some kind of number of dollar question, because really, when we all started, we are scientists working mainly from altruistic or just, you know, or out of curiosity, and we're thinking always about the public and always about the people. But the people are a difficult end user, because getting funding to do all this properly will probably take someone to pay for the entire thing. So right now, our Iliad project is sponsored by the EU, but we are one out of 54 partners in the projects in the Iliad project. Most of them are deal with space and satellites, mapping, oceanographic modeling, and energy, and most of them are companies. Like, not most of them, but many of them are actually companies. And our place as doing this for the citizens is, it will run its course, and eventually we're going to want to target, I think, municipalities first and foremost, like Alan mentioned about the Tourism Authority of Malta. Then similarly, there's Info Medusa who work in Spain and are sponsored by the Malaga municipality. There are 285 coastal cities across the Mediterranean. About 90 of them sit in places where we have okay data from the initiatives. So we see municipalities and probably tourism operators as main clients. If we get good local data, and I'm sure Tomas Moranduso, who will be speaking with us after the break, will detail, if you get good local data and you work with the people, you can actually provide data that is based also on modeling and forecasting, provide a service to aquaculture farms, and who hasn't been tapped yet. And I got a call yesterday from a colleague of mine in a power station in Israel, and he asked me, we hear that this rumor that the jellyfish are coming, and I tell him, yeah, okay, but in my dreams, you are paying me money to do this, because he calls me every season and asks, I don't know exactly what they can do to prepare, but they have stuff that they can. So eventually we're going to want power plants and desalination plants in on it as well. In Israel, half of the drinking water comes from desalination. In Malta, maybe even more, I'm not sure. So we definitely see a place where we can work with them and collaborate with them and actually sell this as a product to them.
Rihanna,
you are muted.
Serena. Serena, have you a question for Dori?
No.
Ah, okay. So,
and we'll be together again soon, I hope. Oh.
Thank you, Dori. Okay. Fascinating.
Okay, let's go on with Valentina Tirelli from OGS. Valentina will present the results obtained in the 3 years of the development of the app. So,
thank you very much. I will try to do this. Okay. Do you see my screen? Okay. Thank you very much to inviting me to speak about Avistap and to show you how to get jellyfish sighting by a click. I confess you that speaking after Alain is very difficult for me, but it's also an opportunity to tell you that Avistap is not a project. Avistap is a crazy idea. It's a crazy idea I had in the framework of the project Noce di Mare, a project funded to OGS in 2019 by the Regione Friuli Venezia Giulia to monitor the spreading of Nemniopsis lady in the waters of our region. That means the Gulf of Trieste and the lagoon of Gradan Marano. For persons that are not very familiar to this area, we are in the northernmost part of the Adriatic Sea. I put a symbol here in red to show you where we were. So when I realized that the area was too big for me and for my collaborators, I start to think how to arrive to accomplish this task. And I thought to call for help to citizens and people. And we developed with the Divulgando Enterprise a new app to collect sightings of Nemniopsis. Okay, in the meantime, as the app was developed, I put also some macro jellies, like meduse, of course, and also dolphin and turtles, because the presence of these organisms is very important to understand the good environmental status of our seas. I know I'm crazy. I will show you. Avistap is a freely downloadable app available for iOS and Android. It is working worldwide, and I translate in English this app in 2020. Citizens can send us sightings, simply taking pictures and sending these pictures through the app. At present, in the app, we put 20 taxa, spanning from ctenophores to jellyfish, dolphin, turtles, and also pinna nobilis and blue crab recently, because a friend asked me to have information, so I add these species to help him. Every sighting is validated by researcher, and since its development in 2019, we received and validated more than 1,050 and 500 sightings. Again, I apologize to my colleagues that are more expert than me in app, but it's just to explain how this app works. I take as example some Ispra jellyfish, because Ispra provides us very nice jellyfish. So if you see Ispra jellyfish, you take your mobile phone where you downloaded Avistap, you can scroll the species, recognize Ispra jelly. And when you recognize Ispra jelly, you are asked to give us information about the quantities of this jelly you are seeing per meter square. These intervals are completely random for the example, okay? And to write also some information if you want to share with me some information. Take the picture and send information. You send information, this information arrives in our computer. And behind this computer, you find only two persons, because as I told you, Avistap is not a project. I personally validated all the sightings, and I spent as Alain holidays, night, morning, doing this, because with no project, this was not my task during the day, you know. What happened? I received the sightings, and this is what I have on my screen. I put here an example. It was me, the person that gave the sightings. These are two pictures of the recent bloom of Rhizostoma pulma in the Gulf of Trieste. We are able to see the position of the sightings thanks to the information of the pictures. And once we recognize that the observation is correct, we validate the information, and the validation immediately give information to the user, thanking for the observation, and give him also the information that the data is correct. And in the other side, these sightings became a data in an Excel file. And this Excel file is freely available for all persons interested to use it. At present, annually sightings are in EMONET biology, but if someone is interested of a certain period, just contact me and I will send him the data. Coming back to what we collected with Avistap in these 3 years, you can see in this pie that Nemniopsis lady was the most cited species in 2018 and 2020. In 2021, we get an equal number of sightings for Nemniopsis and Rhizostoma pulmo. The majority of the sightings here is just a representation during the year. Of course, came in summer, because in summer we had the blooms, and also because people go at sea during summer. But we collected also a lot of observation during coldest months. Nemniopsis lady is a species that was observed and studied through citizen science. Here I report the important paper of Boero and co-authors of 2009, obtained thanks to the data collected with the famous campaign Watch for Jelly, for Italian is Occhio alla Medusa, that give them information about the spreading of Nemniopsis along the western coast of Italy and also in the Ionian Sea here in Calabria. What we collected with Avistap in 2021 is a different picture where Nemniopsis is still present along the western coast, but is also mostly present in the Adriatic Sea. We published this data in the same special issue than the paper of Alain, giving all the data collected with Avistap till that moment. You can see here that the majority, of course, of sightings of Nemniopsis came during summer, but also in red, you can see that the majority of sightings were bloom, high quantity of ctenophores. Here in this corner, I put also a very small paper we made with the southernmost sighting in the Adriatic Sea of Nemniopsis. Again, this is thanks to the help of citizens. And I'm glad to put these pictures because when I received the sightings, the photo was not so clear. So I contacted the person with an email asking him extra photo, if he had extra photo for me. And he told me, no, unfortunately no, but if it is so important, I can come in my last day for holidays again in the same area and send to you a picture. And he did it. He did it. And so I'm here to thank him because what I discovered with Avistap is that at least in Italy, there are many people that are happy to help, happy to study and to give their contribution to the study of jellyfish. And this is one example because thank you very much for this. Here I put some of a summary of my experience with the citizen science. As I told you, I was new to this. Alain knows very well that I'm not a jelly woman. At least I was not a jelly woman before this history of Avistap, because my field of interest is zooplankton. I developed Avistap only for a problem, a task that I had in a project. But after I see that it was so important that the people were so responding that I was not able to stop me. Okay, and now it's a crazy situation, but it's like this. Okay, of course the strengths are that everybody has a mobile in the pocket, Italian even 2 or 3. Okay, so it is easy to ask them to give us information through a mobile. It is easy to use and free, very versatile, because we can collect information also for non-indigenous species and also about many other species. So the opportunities is that we can collect a lot of data very easily. Okay, it's true that it's time consuming to validate the sightings, but it's very different to go at sea with a boat or everywhere than stay in your office and receive information all the day. So it's fantastic. Citizen awareness is increasing with this kind of activities, and they are more interested in understanding the problem about, for example, non-indigenous species. Weakness, of course, Alain told more than me because he has more experience. But the big problem is to promote the app and to keep citizens interested in this. When I asked to Nando Boero his advice about my idea to develop Avistap, he told me, Valentina, is a good idea, but the problem is not develop the app, is to maintain the app working. And once again, Nando, you are right, because the big task is this. So the threats is that the target audience must be willing to participate, and we must continue. They must continue to do so over time. Again, like Alain told us, for us it's important also the sighting every day from the same place. I can even tell you that it's more important to know this than spot observation, because when people came to us asking, okay, how long the bloom will continue? I don't know. Or any other information. We need information also that for citizens are already known, okay? But for us it's important. So thank you very much for your attention. Thank you very much for all persons that contribute in our staff. Thank you for this opportunity and for colleagues that will help me with the suggestion or what you will do. And I want to finish my presentation with an images of what was the bloom last April of Rhizostoma pulmo in the Gulf of Trieste. And the reason why I'm telling to you, Arianna, take in consideration to work with the species, because this can give you big surprise. Thank you very much.
Thank you, Valentina, for your presentation, your advice, and for this effort. This very effort. I understand that it requires a lot of strength. I have a question. If no one have, there is someone that have a question. Okay, Dori, please.
Yes. So far as longevity is concerned, the most important thing for citizen science project is really making sure that it keeps going. It cannot be just a slam dunk, hit and run sort of thing, especially if you want to do monitoring, which is ongoing. For that, the human resources are critical. So I'm asking you, maybe everyone here that is in the field, what do you think can be done in order to alleviate some of the pressure that Alan and Valentina were mentioning? Some of this can be probably automated, but if anyone has any ideas, Valentina, if you want to comment on this, how you can maybe reduce the pressure and move some of it towards maybe the computer doing some of your work.
But to reduce, in reality, we have to multiply Valentina's. Because what I found, for example, I'm doing exactly what is telling Alain, more or less. If you have a clear picture, no problem. Clear picture, big rhizostoma, it's okay. But when you find something that is not very okay, or someone that don't send you the picture, but send the information. So it is the critical, so I don't know if a machine can think like me and Alain. Normally what I'm thinking is that, okay, if it's rhizostoma during the bloom of rhizostoma, no pictures, it was important, it was correct, okay? If they tell me, for example, Ropilema nomadica, oh no, my guys, because nobody seen Ropilema nomadica till now. So I stop, but I take this information in my mind, and if someone continue to speak me about this, I can decide. So machine can help you, but the researcher should be there. The fact is that, sorry, just
microphone.
We should do an effort to collect data in the same way in order to be able to cross the data and to join the data together. Because if you take information, for example, just a simple example, if we decide that the ranges of abundances are the same, this will make the work very easier after.
Standardization.
And I'm ready to change and to develop common approaches.
Okay, so standardization is something that we will be definitely looking at when the data comes in. Yeah.
And I have also another comment, but I take this for the discussion section because I need a coffee.
Ariane, if I may, just 1 minute on what Doro was asking. One way of doing this, since we obviously cannot clone ourselves, is to basically use opportunities which come along. So, for example, if there's students, interns, whatever, and there's obviously summer is the peak time for citizen science, normally marine-based citizen science, we train them, that you'll have them for 3 months, but at least, they can do some of the spade work whilst and they would love to do that, at least for a few months, because they're getting acquainted with the jellyfish species, so they're getting trained, they're getting something. It's not like, you have to do this. It's an interesting job, which people would tend to do for a few months, not more. So we use those opportunities, unfortunately, which come along. So, that's one way of doing it.
Yes, I agree. Good idea.
Thank you to everyone. And then Serena Zampardi of Stazione Zoologica Anton Dorn, we show us a study to define the spatial distribution of jellyfish along the Italian coast. Please, Serena.
Yes, thank you. Okay, good morning, everyone. The title of my presentation, as Arianna said, is Monitoring Jellyfish Blooms Along the Italian Coast, a citizen science-based approach. So, since about 15 years, jellyfish are increasingly abundant in several marine ecosystems. But scientific community did not often recognize the rise of jellyfish, and scientific community is still debating on whether the jellyfish abundance is actually increasing or the jellyfish phenomenon has been pumped up by media. In any case, the recent interest on jellyfish bloom is increased, and due to the detrimental effect on fisheries and aquaculture, on tourism and human health, on power and desalination plants. And several are also the causes of jellyfish blooms, and such as overfishing, global warming, substrates available for polyps, and the introduction of alien species. And take into account the last cause, in the Mediterranean Sea, both indigenous and non-indigenous species established contribute to the rise of the total biomass of jellyfish. But the information on the abundance of jellyfish species is very limited, because on one hand, monitoring activities and the taxonomic identification of these organisms are difficult due to the fragile bodies often damaged by the nets used for the collection. And on the other hand, the scarcity of historical data, at least for some species, made difficult describing their temporal spatial trend. For all this reason, the Mediterranean Commission in 2009 in Italy launched a citizen science initiative that in the years were financed by other projects as Vectors, Coconet, Perseus, Eritmare until 2016. What we ask to citizens? We ask to citizens to send us records of gelatinous organisms from the Italian waters. And first of all, the popular magazine Focus adopted our campaign and created a specific link in which to leave the information requested for the sighting, such as the data of the observation, the location, the name of the species, and the abundance, and the picture when possible. A poster, Occhio alla Medusa, Watch for Jellies, were printed in 2009, and the year after also an application for smartphone was created. For all the period, for the whole period of the campaign, promotional initiatives were carried on to involve people on TV, on radio, and on magazines. So in few years, the citizen science campaign in Italy became very famous. And in 2010, we added to the poster 4 more species, since new arrivals were recorded, and we reached thousands of records. In 2011, more and more species were added, and the poster were also translated in several languages, and we reached more than 3,000 sightings. Year by year, the number of sightings increased until 2016, the year where the project were concluded. And with the new species, the observation of the new species, Pelagia benovici, and with 70,000 of sightings. So we cover all the kilometer of the Italian coast, about 9,000 kilometers, and we identify 27 species around the coast of Italy, including indigenous and non-indigenous species, stinger and non-stinger species. These data were useful also for scientific publication. In 2013, we wrote the first paper, a salt bloom along the Apulian coast in the Otranto Channel between March and May. We also wrote a paper on the impact of stinging jellyfish proliferation along the South Italian coast, especially in Salento waters, and we identify the species that mostly occurred in the Salento water, Pelagia noctiluca, Charybdis marsupialis, and Olindia phosphorica. And we also evaluate the treatment used for each hospitalized case, and we estimated also cost of first aid sting treatments. With this paper, we use the records from citizen science to identify the hotspot area in which to collect the hydrozoan velella velella for digestion and predation experiment carried on in laboratory. We also wrote a chapter for the UCN book on global warming, in which we describe some of the spatio-temporal trends of the most occurrent jellyfish in the Italian coast, according to their life cycle and to the adaptation of global warming. This is the paper that Alan Deydun explained before, in which we compare the spatial distribution of jellyfish report from 2009 to 2014 for Pelagia noctiluca in Italy, Spain, and Malta, with the goals to do forecasting models of blooms. This is the paper we are working now, and we describe all the blooms of species recorded with the citizen science campaign. And with this paper, we will describe in details the spatial temporal trends of each species recorded. And this paper will include the records that we received with the citizen science campaign, and the records and some of the records that we received with the Facebook page Meduse that I opened in 2016 when the citizen science campaign no longer received funds for its continuity. The Facebook page is still active, and we have more than 500 followers that day by day continue to send us their reports or ask us for various information on gelatinous. So to conclude, citizen science data are a useful tool to monitor jellyfish in a wide spatial area, otherwise impossible or difficult to detect with traditional methods, and is an important tool to detect seasonal spatial trends of jellyfish distribution, to observe new species, to select hotspot area for stinger jellyfish, important to manage the impact on tourism, on aquaculture, and on fisheries. So this was my last slide. I've concluded my presentation, and thank you for your attention.
Thank you so much, Serena. There is someone that has a question. I see that Valentina wants to know if Occhio alla Medusa is still working. But Occhio alla Medusa is still working?
Occhio alla Medusa is not working. It's working the Facebook page as instrument that continue to receive records of jellyfish. Yeah, or jellyfish bloom or gelatinous bloom. Especially this year. This year we receive a lot of blooms, of picture and video of jellyfish blooms, especially about Pelagia noctiluca in the Northern Adriatic Sea, in the southern and central Tyrrhenian Sea. We receive also through Facebook blooms of Rhizosoma pulmo in the northern Adriatic Sea. We receive also blooms of Equoria in Collioure in French. This was strange, but sometimes it happens when the Facebook page, when social are famous. This happens to receive also sightings from other countries.
And Serena, have you observed an increase of a particular species and on a particular season? There is a season that where sightings are more frequent.
With citizen science records, you have to consider that mainly we receive records in the summer period. So this is a little gap that we have to remove for the records. So it's difficult to say if we receive if there are more jellyfish in the summer period instead in the winter season. But with this data, we can say if a specific species is present all the season, because if we receive a picture, a video of a bloom of a specific species during winter, it means that in that period the species was present.
Okay.
One tool that we found instrumental in actually looking at deactivating the problem of reporter bias in the summertime is to look at the mean number of jellyfish per observation. It doesn't have to be the mean, it could be the median, it can be a combination, and there are various ways to tackle this, but really taking out the bias of the number of observations is really important. And we found that in our case, for Rhopilema nomadica, the mean number of jellyfish observed per observation worked well as a proxy. You've probably played with this already. Yeah.
Okay. Thank you, Dani. Thank you. So we are concluding our session with Laura Giusti, that will present the experience of Mediterranean, a trained group of people, ordinary citizens and sailors that monitor the status of our sea and collect precious data. Please, Laura.
Yes, hi everyone. I'm just, can you see my screen?
Yes.
Okay. So thank you very much. Yes, I will be presenting Progetto Mediterraneo as an example of citizen science as well. So a direct experience of advanced citizen science and the scientific impact in the Mediterranean. Yeah, I'm trying to move forward with the slide. Okay. Okay, so now it's working. Okay. So basically, I'm just spending a few words to present the project before just focusing on the scientific objective and the citizen science we were talking about. Basically, Progetto Mediterraneo is a nautical, cultural, scientific, and social expedition that was born 10 years ago. And basically, we are just citizen, normal people who love the sea, and we decided to just sail all the Mediterranean, to know the Mediterranean, helping also the research and the study of the sea, of all the species in the sea. And we did more than 20,000 miles over these 10 years. And after this amazing experience that we did in the last 10 years, we decided to move on. And the project now is absolutely expanding a lot. Is open to anyone who also would love to come on board, just checking the sharing of our values, basically. And today the boat is in the Aeolian Island. The course this year is going to be Sicily, the Pelagie Island, Malta, Lampedusa, Pantelleria, and then we just sail up to the north of the Adriatic Sea, up to Venice. And next year, we will be sailing in all the Croatia and Greek island. Just to introduce a little bit the project, because it's just not only a scientific project, but now, of course, I just focus on the scientific objective and the citizen science aspect of the project, thanks also to the collaboration that we started a couple of years ago with ISPRA, with the main aim of starting monitoring all the area where we were sailing, because being like a sailing boat, we just sail over many areas of our Mediterranean. And for us, was like a big opportunity to share and to give the opportunity to have common people on board and just to sensibilize them as much as we can in terms of data collection, monitoring, focusing on marine littering, plastics, also cetacean like whales, dolphins, and last but not least also, of course, jellyfish. So basically, what I wanted to focus, I'm happy that I heard a lot talking about citizen science. It's something that it's really wonderful to know, even more now that we are just knowing each other in this nice workshop, that there are many other projects and many other occasions to develop the citizen science. But what I would like to focus on is that we like to call our citizen science as advanced citizen science. What's the main difference for us? Basically, advanced, we mean that we are a group of people that are like very careful actors in data collection and sea monitoring, but just following proper procedures coming from ISPRA guidelines as well, because just before starting our agreement, we did a full training program with them. So I'm the responsible for the scientific projects on board, and one of my aim is just to train the people working with me and with us, just to properly apply scientific method and having scientific approaches with precise and standard and measurable and methodical rules and procedures as per the scientific world, because we are not biologists, but we have been trained and we properly know what we do in terms of data collection and sea monitoring. Focusing on jellyfish, of course, one of the species that we monitor and we look after while we are sailing with the Mediterranean, and thanks to Project Mediterranean, are jellyfish. Here you can see all the species of jellyfish that also Serena was mentioning earlier. And this is an example of what we do on board. We have an app that has been downloaded in our tablet, and here during the marine littering sightings, you can see here in the picture also that there is like a proper department dedicated to jellyfish. Here there is an example of like a member of the crew of that week on board, just looking at the sea and spotting any kind of marine littering or anything that we can see on the sea. Also, of course, jellyfish as well. This is some other picture of what we do on board, and in the app it's really important to collect most of the data that also you have already mentioned earlier, both Serena and Valentina, also Alan and Dori. This is an example of our monitoring form, where basically it's really important to us to know the type, if it's possible also to take a picture of the jellyfish that we spot. Of course, putting the location, so the latitude and the longitude of that type of jellyfish, the quantity, if it's just a single one or a bloom or in which shapes, that's for sure. also the distance among people, if it's not, for example, while we are sailing, but maybe while we are walking on the beach, or eventually we can spot them also while we're diving or while we're swimming, because we leave the sea at the 360-degree level, and the boat is most of the time on the water, mainly like 9 months per year. So we have many opportunity to do this kind of advanced citizen science from different perspectives. So, and these are two of the forms that we have on board, that every week of the expedition, the referent of the scientific project has the objective to fill in anytime we spot and we see jellyfish, but not only, because of course we do citizen science not only for jellyfish, but of course I wanted to put the focus here on jellyfish because we are talking about them. So, and that's pretty much what I wanted to present. And I don't know if you knew already Progetto Mediterranea. I'm happy also when Alan said earlier that he was focused more on Malta and that kind of Mediterranean part, and that now is the time to have a Mediterranean project. And we have already a Mediterranean project eventually, and we are absolutely happy and hoping to see any synergy and any touch point or opportunity to work together to spread out as much as we can this kind of messages and sensibilize people and citizens as much as we can to support the science and the research from this perspective. So I thank you all, and I'm available to answer any question.
Oh, thank you, Laura. Thank you very much. But have you thought of your beautiful boat? Of the boat, of the vessel?
Yeah, actually, yeah, this is the boat. Actually, I could have put, yeah, but in our website or in our social media, Instagram, Facebook, if you look for Progetto Mediterranea, and this is the logo, because sometimes this is the logo. Sometimes, because there is another Mediterranean boat, but we are Progetto Mediterranea. Mediterranean is the name of the boat, and this is the logo. So in our website, that is www.progettomediterranea.com, you can see anything, also our press releases, anything that we do with all our partners, not only ISPRA. So it's like it's something that is touching different aspects of, let's say that the main object for us at the beginning was just to realize a dream, to know and to discover the Mediterranean, just proposing also a sort of a different way of living. No? So yeah, and we would be happy to have you on board if there is the chance also to meet some of you during the course of the boat, because as I said, the boat now is in Sicily, and then she will sail towards Malta, and then from Malta to Lampedusa, Pantelleria, and then sailing up to Venice, and then for the future we will keep you posted. But yeah.
Thank you, Laura. I guess that all of us, we will be very happy to collaborate with you.
Oh yeah, I mean that could be an opportunity, because it's like a sort of movable platform where we yeah, all the people are on board would be really happy. Also my colleagues and my the other Mediterranean guys and girls would be happy to leave an impact on this world, you know, because we are all I would like also to say that just up to now, and the project is on since 10 years, the project is a self-found project actually, so far. So it has been brought on just through the passion and through the love of all the people on board, and this is something that is a really an added value to me and to all of my colleagues and collaborators for sure.
Thank you, Laura. Sorry, we are a little bit late, and before leaving for the coffee break, I want to thank you, the organizer of the workshop, in particular Attilio, Sabrina, Arafa Farris, and Roberta De Angelis. So we reconnect at noon. Now there is a little coffee break. See you later.
Oh, short question? No.
Yeah, eventually we can stay connected as well through emails. Otherwise,
you're in discussion, okay, Laura?
Yes, absolutely. Yeah, I'm super available, and my contacts are also with the ISPRA team, so we can connect each other.
Okay.
Thank you very much.
Sorry, Valentina, I didn't see your hand up. Sorry.
Also, Dori, I think that also Dori had a quick question.
Sorry.
It is very short.
Yes, please.
Laura, I didn't explain during my presentation of Avistap, but in Avistap there is the possibility to create campaigns. That means that if you want, we can open a Mediterranean campaign. Okay. And if you enter in this campaign, all your sightings will be in a data set. And when you arrive, I can give you in Excel. For you, okay? If you want, it's easy to do, and we can create a campaign Mediterranean.
Okay, so thank you very much for the.
So in this way, all your sighting will be very easily identifiable and
downloadable and anything.
Of course, they will be on the entire data set, but I can take them separated for you.
Okay.
Easy to do, fast, and so if you want, I will be happy to help you with Avistap. And also thank you very much, because you do a very interesting job, and especially you are able to give us information about what is happening offshore. And this is not easy to collect, because the majority of sightings came from coast. Yeah. But we know that coasts are just the border of Jelly, but the environment is the open sea.
Yeah, absolutely. So thank you, Valentina, and I will be back to you offside. Yeah,
okay. Thank you.
Dori, do you have a quick question? I saw that
Svitlana?
No. The audio is off.
Valentina preceded me. I was wondering whether the data was actually flowing right now into one of the databases. But really, I think that every area that you will be in, also some initiatives are pan-Mediterranean that you can report in. So, choose wisely. I think what Valentina offers is a great opportunity. If you can actually create your own project for your purposes, can be good as well. Eventually, hopefully one day, I will be looking at those lines of reports and adding them to the Mediterranean total. Would gladly so.
Oh, thank you very much. Thanks. Thank you.
Laura, Filippo Piccardi is asking if in the project Mediterranea, have you ever spotted Leucothea multicornis? Cause in the sea waters in front of Venice we saw more.
Okay, not at the moment, but I will take note, because we will be in Venice at the end of this season. So definitely we will pay attention to that. Yeah.
Filippo, we have it in the Gulf of Trieste.
Okay, thank you. Okay, see you soon. We have 15 minutes of break, and we reconnect at noon. Okay, thank you.
Thank you.
Thank you. See you later.
Good morning to all. Welcome back to the second part of this workshop. I wish to thank Arianna Rasi and all the speakers of the first session for all the interesting information that they show us in their presentation. In this second session, we will mainly focus on methods for dispersion and forecasting of jellyfish blooms. I'm Antonello Bruschi from ISPRA, and I will share the session. We have seen in the first part of the session of this morning that the topics of forecasting the presence of jellyfish bloom and identifying the paths of transport from offshore close to the coast is something that already emerged in the morning, even in presentation dedicated to observation. Now, in the second part, we will focus on specific on this issue. The first presentation is from Svitlana Lyubertseva and Giovanni Coppini from the Euro-Mediterranean Center on Climate Change. And the title is Lagrangian Modeling, the Jellyfish Drift, Capabilities and Limitations. I will share the presentation on behalf of Svitlana, so give me a few minutes.
Thank you, Antonello. Thank you very much.
Okay. So, Svitlana, the floor is yours. Let me know when I have to switch slide.
Yes, thank you very much. I'd like to talk about Lagrangian modeling as a drift of jellyfish, as the main capabilities and limitations. As a overall task is to forecast the jellyfish outbreaks. It means that we need to know at least two things. First one is information about pre-outbreak conditions, and second one, triggering factor. This kind of forecast is very difficult, especially triggering factor. This kind of modeling, similar to modeling hurricanes, near bottom hypoxia, red tides. So the task is quite complicated. Next one, please, Antonello. The problem of coupling biochemical module with hydrodynamics module is very, very complicated. Is the most complicated thing in coupling problem. Because when we talk about living organisms, we need to take into consideration food and growth related processes, transport related processes, and predation related hypotheses. Lagrangian modeling works with transport related processes. Lagrangian modeling tracks virtual particles of zero spatial extent, passively driven by ocean hydrodynamics, which includes currents, waves, and sometimes wind. We consider jellyfish as passive tracers. Additionally, some scientists include active vertical migrations with diel cycle. Additionally, we can consider so-called subgrid scale diffusion, which can be formalized by random walk scheme and random fly scheme. You can see here the life cycle of jellyfish, and Lagrangian models works with movable stages of jellyfish, ephira, and mature jellyfish, medusa. Polyps are sometimes considered as a source of these two movable components. Please, next one. I'd like to overview several works. It was not exhaustive overview, but in order to demonstrate how to say level of development of Lagrangian models. On the left, you can see modeled species, in the center basin, and reference. And these works are connected with modeling of jellyfish in Gulf of Mexico, in Baltic Sea, in East China Sea and Japan Sea, and Pelagia noctiluca for the Mediterranean Sea. Next, please. Modeling of jellyfish in the Mexican Gulf. The objectives was to estimate time and distance scale from probable polyp habitats to areas in which the medusa are observed. The source polyps are situated in squares on the map. In squares are sources, polyps. And then from sources, by means of model currents, vertical particles are tracked up to final location, which is drawn like a triangle for different years. On the right, you can see the main hydrodynamic structure of Mexican Gulf, which is called loop current in blue. You can see how this current enter and exit the Mexican Gulf. This current is very famous for, first of all, Deepwater Horizon oil spill. And we can see that there is interannual differences in tracking these virtual particles. And the second one is the explanation that these particles, which could model jellyfish, they are transported by a loop current. Next one, please. Next paper by the same author is about medusa in the Gulf of Mexico, but this is the inverse problem. We know where this medusa is situated in squares, and we track, we solve the equation of displacement backward in time, and we see that this medusa was transported from the outer part of the Mexican Gulf, from the Caribbean Sea. And the reason, the main transport mechanism is again loop current. Next one, please. Before we consider very simple approach when jellyfish was modeled as a passive tracer without diffusion, without migration, only how to say passive particles. In this case, additionally, we consider 3D transportation, three-dimensional. We consider vertical distribution. This medusa was modeled for the Baltic Sea, and they did it not only for adult medusa, but also from Ephira, which were grown in time, and they had a very good monitoring data set. The kind of data you can see in the center when there is not only the horizontal position of a jellyfish, but also vertical distribution, then distribution on day, on night, the distribution of temperature, salinity, and oxygen. And on the left, there are results of this modeling. 1, 2, 3. This is the sources. This is the polyp stage of the medusa. Then by the arrows, they show the main direction of transport. And they found 3 main directions. They track this medusa for quite a long time, and they consider not only passive particle but the state of this particle, if this medusa at state of ephira or in state of adult medusa. Next one, please. This is work for modeling made in East China Sea and in Japan Sea. Again, study of hydrodynamics and influence of hydrodynamics on jellyfish transport. It was a 3D advection, so again, a vertical movement was also taken into consideration, and random walk, horizontal and vertical diffusion. As a rule, people tend not to apply random walk schemes to live organisms because the behavior of live organisms are supposed to be more complicated than random walk, random diffusion. On the left, you can see sources. Sources now is not a point, is massive and situated in the river mouth. And in the center, the result of final distribution. In blue, from the northern river, and in black from the southern river. And in the left, observations and comparison with observations. Next one, please. This is a most how to say complicated model, because in this model Pelagia noctiluca is regarded as active swimmer, which have active vertical migration with a diel cycle when they migrate from 5 meters at night to about 305 meters at days. Plus horizontal transport with the ocean general circulation model. And in this case, again, they track ensemble, not one particle per source. They started tracking from blue rectangles. This is a western part of the Mediterranean, near the Côte l'Azur and Gulf of Lion. Red particles are tracked from 5 meters, and green particles are tracked from 100 meters. The main conclusion is the main conclusion can be seen in the left panel, when we can see that in this area the main hydrodynamic feature is northern current, which transported particles along the French and Monaco coast. And this current is quite strong, and sometimes transporting of this current blocked penetration of particles, in this case jellyfish, to the entire area of Gulf of Lion. This is the mechanism which is typical for all admixtures which are transported by strong jets. Next one, please. Again, the same Pelagian Noctiluca in the Ligurian Sea, the same area. In this area, more complicated approach. The sources of medusa are in black dots, and two processes are taken into consideration. Horizontal transport with general circulation model, and the active vertical migration with diel cycle, again without any diffusion. They tracked a big ensemble of virtual particles during 10 days, and colored circles express the value which is proportional to concentration of medusa after 10 days of traveling from black dots. In red, high concentration, in blue, low concentration. The big circles are observations. As you can see, observations are very rare. Big circles, great number of medusa, small circles, few medusa. The conclusion is that abundance can reach maximum in base and in lee of capes, and two factors impact jellyfish: the position of the main jet of northern current again, and the wind. Next one, please. This is conclusion. As you can see, the models can be explanatory, that provide explanation of observed empirical patterns, inferential, that quantify the relative contribution of different processes to producing the observed patterns, and hypothesis generating, that is led by hypothesis that could be tested by modeling. Then you can see that Lagrangian models for jellyfish are at early stages of development. Really, they consider a living organism as passive tracers that moving deterministically with the maximum with they are carried by 3D currents, and they exposed to diel migration cycle. The level of complicity of models should correspond the quality and quantity of observations. And the last conclusion, that if society needs good models, we are ready to produce these models. So development of models is driven by social needs. Thank you very much. I'm ready for your questions.
Thank you, Svetlana. So, are there questions for Svetlana? Okay, I have one. In the last point of your conclusions, you said that Lagrangian models are ready for development. So, how do you see that? What will be the first development in Lagrangian models in order to fit with the experiences that you have seen? Do you think it is more important to start with identifying pattern of transport from sources to towards the coast, or do you think it will be more important or more urgent to link with observations and hence developing short-term forecasting systems?
Thank you for the question. A very good question. Connection with the observations is a must, the main thing. And the first question is sources. Where is sources? If we consider polyps as sources, then if we do this, we need to take into consideration the life cycle from polyps to ephira to adult medusa. It's very complicated. Nobody did this before. Second approach is that we know for sure from observation from citizen science that we have pre-outbreak conditions. So some concentrations of medusa in some areas, and we start tracking forward in time, moving of these organisms by currents and waves, first of all, not wind, of course, and plus vertical migration. Vertical migration is very important. Otherwise, we could not, validate the observations. The observations should be also, divided, like in the Baltic Sea, daily observations and night observations. And if we, I guess that night observations are very, very rare.
Thank you, Svetlana. Are there other questions? So not at the moment. Thank you, Svetlana. We will be back for the final discussion. So the thank you. The next speaker is Thomas Moranduzzo from Colombo Sky, and the title of his presentation is Jellyfish, an ocean monitoring tool to predict jellyfish swarms. So thank you, Thomas. The floor is yours.
Thank you, Antonello. Put full screen here. Okay. So first of all, thank you to the organizers for inviting us to present here today. It's really a good opportunity for us. With this presentation, as Antonello said, I will be presenting one of our tools, Jellyfish, a monitoring tool for the prediction of jellyfish swarm. First of all, I will give you a very short introduction about the company. I will explain who we are, what we are doing, why we are doing that. And then I will move on the core part, presenting our tool, Jellyfish. So Colombo Sky is a private company established at the end of 2017 with the idea of bringing together the skills of the founding team, skills ranging from remote sensing, machine learning, oceanographic modeling, to create something for ocean monitoring and environmental protection. With these ideas in mind, we presented a project to the European Space Agency, who, together with Latinova, granted us 2 years incubation period, where we were able to develop most of all our ideas. The main idea of Colombo Sky is to create a platform, a web application accessible to everyone, to understand the ocean water quality, and also to understand what is going on in the future. So being able to predict condition of ocean water quality, but also to predict the approaching of water threats like marine debris, harmful algae bloom, jellyfish blooms, oil spills, because all these water threats are affecting a lot of industries related to the maritime environment. For that reason, we created AquaX, which is a web platform tailored, created specifically for the aquaculture industry, but also it can be used for other industries, that integrates satellite data, in situ data, oceanographic models for water quality monitoring for the real time, but also thanks to the oceanographic models for the prediction, for the forecast of what will be going on a specific location. That is extremely helpful for when we talk about water threats like jellyfish bloom, because knowing 2 days in advance that a jellyfish blooms could be approaching a farming site or a power plant is extremely helpful to let the user take action, take mitigation measure to reduce the losses. This is the dashboard of our platform. It's a demo dashboard where the user can get access and have a quick summary about the status of their facility, if we are talking about aquaculture farming, but also the status of specific location they would like to monitor, having a quick overview about chlorophyll concentration, salinity, sea surface temperature, but also information about water threats, jellyfish, oil spills, harmful algal bloom, and other water threats. Now, moving on, the core part of this presentation, I will describe Jellyx, why we created that, and how the user can take advantage of this service. So we already saw during this workshop the impact of jellyfish outbreaks. They can affect a lot of industries. They can collapse fisheries. They can be an issue clogging the cooling system of power plant. They can kill fishes. They are a real problem for the tourism industry. For all that reason, we decided to apply for a project promoted by Mercato Ocean, user uptake program, to develop a tool being able to predict the presence of jellyfish. Obviously, not obviously, but from satellite, it's especially from optical satellite, it's really difficult to see jellyfish, because jellyfish can be really small, they can be under the surface, so it's extremely difficult. So our approach is not to directly detect the presence of jellyfish in the water, but to provide the user with information if the environmental condition in the water, in the environment, are likely to favor jellyfish blooms. They are likely for the proliferation of jellyfish blooms. So what we do is we collect a lot of data from satellite. So we use Sentinel-2, Sentinel-3, but also other satellites. We use oceanographic models. We use in situ data, for example, not just the ground through about the observation, the sightings of jellyfish, but other data like, for example, rain precipitation. We integrate all of this data to predict the area that are likely for the proliferation of jellyfish. I want to spend just a few seconds explaining why the use of oceanographic model in our case is really important. I think we already discussed during this workshop early today, but I want just to clarify. Using just optical satellite data is not good, because satellite data, especially in some area of the world, they are affected by clouds. Here you can see the coast of Chile, which is one of the areas most affected by the presence of clouds. So if we would use just optical satellite data, we could face entire week of no data. So we wouldn't be able to provide the user with an information. So what we are doing is to integrate satellite data, Sentinel-3, Sentinel-2, with the global oceanographic model to create high-resolution oceanographic models specific for custom areas. high resolution, both in terms of temporal resolution, but also in terms of spatial resolution. We found that a good range of spatial resolution goes from 150 to 200 meters of resolution. Here I'm talking about in relation of the service we are providing. We are not providing in-point information, so a specific information about a single spot in the water, but our goal is to provide a wide range monitoring. So 150, 200 meters resolution, which means that each single pixel of this map represents a square of 150 or 250 by 250 meters in reality. So this kind of resolution, it's a good compromise and can provide really good information for the users. So that's why in our services, we integrate oceanographic models to overcome the problem of clouds, but also to provide them with a higher temporal resolution. Quickly, the workflow of Jellyfish. So as I already said, we integrate data coming from different sources, satellite, in situ, ancillary data. We use a lot of services from Copernicus, Marine Copernicus. We combine all them together, and we extract the features that we understood to be more relevant, to be associated with the presence of jellyfish. We trained an artificial intelligence model, a machine learning model, and thanks to that, we run every day to create a risk map where the user can understand the risk presence of jellyfish. This model is constantly updated when new data are fed into the system. Now I will show you how, but these data are constantly updated to be, let's say, updated with the current environmental situation. The results, here, our goal was to provide an actionable information to the user. Not all the users are expert in jellyfish abundance, jellyfish density. They just know that jellyfish is a problem. So what we wanted to do is to provide an information that could let them understand, okay, I have a risk, okay, I'm safe here, I don't have to take any kind of mitigation measure. So our idea is to create an index with a traffic light logic, where green means no risk of risk presence of jellyfish proliferation, where the green is associated with a density of 0 individuals per 10 meters square. Then yellow is a medium risk with an association of between 1 and 10 individuals per 10 meters square, and high risk, red, with more than 10 individuals per 10 meters square. A red usually means a high risk of a proliferation of jellyfish, a high risk of jellyfish bloom. During the user uptake program, we evaluated the JellyX service all over the Mediterranean. So we collected a lot of data, a lot of sightings from different projects. Some of them also presented this morning. So we collected a lot of sightings, and it was an issue at the beginning for the standardization of collecting the data from different projects. And because as we saw this morning, all the projects collect data in a different way. So we had to standardize all the information with this traffic light index logic. And in this way, we estimated an average accuracy of 75% of detection on estimation over 12 jellyfish species, the most common in the Mediterranean, the most cosmopolitan in the Mediterranean Sea. Inside AquaX, how you visualize this information? Here, the user has set up on location of interest in this area. And you can see, for example, for the full month here, there were no risks associated with the presence of jellyfish. And here, suddenly, we had a peak. So a high risk of jellyfish bloom. Here you can see the red area in the map. So in this area, we estimated a high risk of outbreak of jellyfish. In this case, we would have sent the user an alert, an email 2 days in advance to let them take mitigation measure. Inside Aquex, the user cannot be just warned about alert and visualize the map and see the actual status of an entire wide area, but also they help us to improve with the system. They report jellyfish observation, also with the logic we implemented. So they can simply go inside the platform, they decide, they provide us with information about the jellyfish species and also with the density they spot. There are some limitations with this approach. We already saw that, but in this way, we can collect a lot of data and we can every day, every week, every month, retrain the system with new data in order to improve the accuracy. So what are the benefits of GellyX? In this way, you have a large-scale daily monitoring. So you have a complete overview, a wide range overview about a location, and you understand if jellyfish bloom is approaching a farming site or a power plant in order to take action. You have a forecast capability because thanks to the oceanographic models combined with machine learning, we can give information 1 to 3 days in advance in order to let the user take action. And also here we have, we developed this index with a very easy to understand information. So the user can go into the platform and they see red, so they know there is a risk. And they also can transmit this information in an easy way. They don't have to interpret the data, so they don't have to pass from, okay, I have a 10 individuals per 10 meters square of jellyfish. What does it mean? So they have a clear understanding of what's going on. So with this tool, they can lower the risk. They can protect they can protect basically their profits. Okay, thank you. For any question, please ask or contact me later. Thank you.
Tomas, thank you for the presentation. If I may ask a quick question, something about the density that we are about to tackle, and we were wondering whether we can learn from your experience, is that for certain species, also for the modeling actually, for certain species, some models and some figures will work better than others. For example, Nemiopsis, for example, it could be that even 10 species per more than 10 species per square meter is really okay, but 1 species per 10 square meters is not exactly what you would call yellow. Or for Opilema nomadica, for example, which is large and conspicuous and very stingy, you can take a density of 1 per 20 square meters, and it will still be considered a swarm. So my question is whether you would, I think, first of all, your attitude is if it works, then it's great. But the second attitude that one might take is to build something a bit different for every species. This makes, for reporting, for sure, this makes life a lot harder for the people who do it, and but maybe it will increase the level of accuracy of the models.
Well, first of all, thank you for the question, and you are absolutely right. You spotted the point. We started following this approach because of the lack of data at the beginning. So we had to find a way to combine the data from all jellyfish species. Now that we start having a good amount of data for all the species, what you describe is the way to go. You need to have a different model for each single species. My concern now is, since our goal is always to provide a clear information to the user that are not expert in the field, we need, in any case, to find a way at the end of the model for each single species to provide a clear information that summarize everything. And if you have, for example, a density of 1 species and a low density of another species. How you say that to the user? You cannot provide 10 different indexes for 10 different species. You have to find a way to summarize. So that's, I think, one of the key points we need to address before splitting or having a single model for each different jellyfish species.
Okay, thank you.
Yeah, there is another question from Valentina.
More than a question, more than a question. I'm sorry, but I'm a bit critical about your approach. I understand why, but sincerely, from a jellyfish point of view, I'm a bit astonished. Probably I don't understand all the passages, so please help me in this. In the beginning of the talk, you told us that your aim was to give scenarios of prevision of the presence of the jellyfish, not to collect data about the jellyfish. That means that you collect a lot of data from previous year even, and this is your knowledge about jelly in that area. And on this, you built your model, I'm right?
Yes.
Okay, this is the first mistake. Because if you listen to, for example, Alain in the beginning of the talk told us, I don't understand. I'm looking the sea around Malta since I don't know how many years, and this year is completely different. And this is a big challenge with jelly, because jelly are very, very difficult to monitor in order to make prevision. I make sometimes a similarity between jelly and earthquake, okay? You can understand how they function more or less, but to be able to say to people, here you will have a bloom of this species. If you arrive to this, I candidate you for a Nobel in natural science, because it's very, very difficult. You can give them the probability that in that area you can have more possibility to encounter this kind of jelly, but not more than this, because it never happened in the same way. We know that. Okay, so if my suggestion for you is to create a model more near to real data in time, also to change the model with information very, very near to your prevision, not a very long time spanning prevision. Okay, and secondly, about the risk, it depends on the species, like Dori told you, and also on the sensibility of person. I agree with you that it's difficult for you to arrive to a single product in the end, but you have to manage this, because one Cubo medusa, just one, has an effect that is very different from 1,000 of Equorea. So the diversity is something that we have to manage. We cannot say, okay, as we have to summarize, it's the same if you have a Cubo medusa or if you have a Equorea or Memniopsis. It isn't the same. I can tell you that it's a good approach. You have to pass through the diversity and create something more strictly related to what really you observe. For me, sorry, is my opinion.
So Thomas, we have two questions here together. So try to answer first to the first one and then to the second one, in order people to understand the different part of the.
Sure. Well, first of all, thank you for being critical. It's what we are looking. If everyone say, okay, your approach is fantastic, we'll never improve. So thank you for that. What you said is it's right. We cannot, let's put it this way, we cannot always predict the presence of jellyfish because the environmental conditions are different. We know in Malta last year was completely different from this year. That's why we are not having 100% of accuracy. If we would have 100% of detection accuracy, probably we will not be here. We will already have the Nobel Prize, as you said. We are having a 70% 75%, 80% from some species of accuracy of prediction. Our goal is to help the users, aquaculture farmers, power plant owners, to give them an indication about the risk they are facing. So we are not saying tomorrow there is a jellyfish bloom. Tomorrow there is, given the environmental condition, given what we saw in the last 10 years, there is a high risk of jellyfish. So we are trying to give them an instrument to reduce losses, to put in some kind of mitigation measure to let them reduce losses. We know it's never 100% accurate, but we think if you give them 75%, at the moment it's better than nothing. It's a good way to start. And the other thing here is, you're right, having one single detection model for everything is not the right approach. We know that. We are trying to move and creating something more wide that can work for all the species in order to provide the user with the right information. We are at the beginning of this journey. We couldn't start directly with everything. So we started with having the basic service, and then we are starting to improve here.
Understood.
Okay, we have two more questions, but before leaving the floor to the other people, I have one question related to the first question Valentina made. So in your presentation, you highlighted that you make a training session of your model. Does this mean that you use artificial intelligence to help you relating environmental conditions and jellyfish presence related to what happened in the past?
Yes, absolutely. It's not, sorry if I wasn't clear during the presentation. We don't have like a threshold and we say, okay, it's over 25 degrees, you could have jellyfish, or it's you have this kind of chlorophyll concentration, you can have jellyfish. We combine all in situ data, satellite data, oceanographic models with an artificial intelligence model that is trained with all this data correlated with sightings of jellyfish in the water. And after that, we have our risk map. That's the workflow.
So this is what helps you in dealing with anomalies such as those highlighted by Alan this morning. So if you have different environmental conditions, your model is able somewhat to understand if you will have again a jellyfish bloom or not. So this is also answering to the first question of Valentina.
Yes, it's not that every day we look at the precipitation, the salinity. It's the model that does the work for us here.
Okay,
yeah,
we have...
Just to clarify a point. I think
yes,
it's very
yes,
important.
okay, please.
So from my knowledge, but we are here to discuss, so I am happy also to change my advice, you know. And if I seem you to be too critic is my personality, but I appreciate person that try to solve problems. So you are in my top classification. But at present, if you ask to people working on jelly, if they can tell you exactly what are the environmental factors that determine a bloom, is impossible to answer at present. Okay,
that's why we are asking
we can say that there are several conditions that are often present, but we cannot explain this. Is the reason that I told you that blooms are more or less like earthquake. Okay, because after the bloom, you can say, okay, temperature, maybe that year was temperature or more or less like this, but you are not able to, in my knowledge, to join some environmental factors that tell you at 75% the possibility to have that kind of bloom. Otherwise, it's impossible to explain why the Adriatic Sea is not continuously full of a lot of bloom of several jelly, and we don't experience this kind of problem every year in the same way. Okay? So, and the reason why I'm telling you, join the more that is possible for you, observation observation at sea to your model, because otherwise you go too far. The risk is to go too far from reality.
Yes. Well, I understood that probably here we have a different approach on solving the problems. I have more an engineering machine learning approach, while yours is more a biological approach. I know that predicting a jellyfish is like predicting earthquake, but I believe also that there are some correlation. So you cannot find jellyfish everywhere. There are for sure there should be correlation if you combine all the environmental factors from the water quality, air quality, precipitation, closeness to port. You should have some correlation, and the machine now are able to do that, to detect this kind of correlation.
But wait, I'm thinking that there's a miscommunication here. Thomas, you guys do have observations, right? That you look for ground truthing, and so Valentina, maybe that wasn't conveyed in the right way, because they are relying on that's how I understood it, on observations as well, not only
observation in the past, not observation made that week.
We also have information that the users are feeding in the system. Maybe not every week, because we know we don't have jellyfish bloom every week, but they are constantly feeding the information in the system. So we collected a lot of data in the past, and then now the system, through the platform, the users are feeding the information. So we recalibrate the system every time we have new information.
Okay, we have two more questions. Anyway, I think this is off the topic of the workshop. Actually, this is the magic of machine learning, because machine learning is able to take into account variations of several variables at the same moment, and covariation of several variables. That is something that is difficult to tackle in studies carried out by people. So this is the power of machine learning, and in order to get more details on this, we need a complete workshop. So I think we can't go further on this topic. Anyway, thank you, Valentina, Dori, and Thomas for this part. We have a question from Serena. So please, Serena.
Yes, it's just a curiosity, because you talk about low, medium, high risk prediction, right? And my curiosity is, what do you connect the outbreak risk to? Because I mean, you mentioned many taxa, Schifozoa, comb jellyfish, salpa, but some outbreaks of these species have detrimental effect, have impact on tourism, aquaculture, etc. But some others do outbreaks, do blooms without any direct effect. So when you talk about low, medium, and high risk prediction, what do you consider as risk?
I'm not sure I understood the question, but I try to answer. We consider as risk a density bloom, regardless of the species at the moment. So a high concentration of jellyfish in the water.
So independently from the impact.
Yes.
Just the bloom. Okay.
Just the bloom, exactly.
Okay, thank you. Because we need to be careful because the risk is to spread false alert, because people scared about jellyfish. Jellyfish are impact on many sector, fisheries, aquaculture. So when you talk about risk prediction, you have to consider that there will be no impact, just the bloom. This is important for public, I mean.
That's a good point. That's actually a really good point. We never thought the issue from this point of view. We will consider that.
Okay, thank you.
Anyway, I wish to highlight something that today we have seen, we have another question after this consideration from Svetlana, that today we have seen a lot of actions financed by research projects. Actually, this is a commercial tools, so it's not public, it's aimed at customers, and hence they have to answer to their customers. So they have to provide what the customers want, and they are evaluated against the questions of their customers. So correct me, Thomas, if I'm wrong.
No, you're right, exactly. When we started creating this tool, we collected a lot of feedbacks from aquaculture farmers and other users, asking them how they would have liked to receive the information. That was the compromise between all the feedbacks we had. So you're right. We asked them, and that's the way they wanted the information at the moment.
Okay, so we have another question from Svetlana.
Maybe very technical. Do you use linear regression in machine learning?
No.
And the factors which influence concentration of jellyfish, if they are independent?
Well, we have a long list. Now probably we are going even too technical also for me. So I will have to ask my colleagues here. If you have a specific question, I can put in contact. We use deep learning, convolutional neural network. So we can combine everything. But if you have a specific question from this technical point of view, please contact me. And discuss that.
Okay, later. Yes.
Okay, thank you. Thank you, Thomas. Thank you to everyone for the presentation in this second session. Before closing the workshop, there is a question from the first session that we have to recover. It was from Filippo Piccardi, and it was aimed at Arianna this morning. And the question, actually, I don't have it in the chat. Anyway, it was if the tools you showed is able to detect also species different from jellyfish, such as salps and other species.
Well, with SAR images, we are able to detect jellyfish that swim on the surface, sea surface. So we are not able to see what is below the sea surface. And then maybe we take into account at the moment Pelagia noctiluca and Velella velella. And maybe as suggested from Valentina, we will try with Rhizostoma, but that's all. I think that these are the species that we are able to detect.
People and I think that he refers to Mnemoniopsis.
Sorry, Valentina, you have to start again because your connection was not working.
Oh,
so
sorry. Arianna, I know very well Filippo Piccardi was my student during his university studies, and I think that his question was related to Mnemoniopsis.
Okay, thank you. But as I said, maybe for the moment, at the moment, only Pelagia and Velella velella.
Oh, there is another question from Svetlana.
This is question for the discussion for all.
Yes. Yes, please.
Is it possible now to replace regular monitoring of jellyfish by citizen science detections?
Good question. Who wants to answer? So
me.
Yes.
Me, because it's something that I would tell you in the end of this meeting. I profit that the host of this meeting is ISPRA, and so my answer is mainly related to Italian waters, not to the water of all European seas, but for Italy. We are very lucky that in the framework of the marine strategy, there are regular monitoring for jelly, macro jelly. My question for you is, Pratim, if you are powerful guys, and I don't know if you can decide for this, but for example, if a person working for this kind of monitoring that are very regular each month and made by person that knows very well the species, so they don't need to take the pictures, because for example, in every staff, persons that are considered the person that knows very well jelly can send just the information without the picture. If we ask them to send this kind of information in the app, for example, we can have the data very fastly. And qualitative data, we don't need to have all the transit, but at least spot information about the presence of jelly. If we ask this to all people involved in the marine strategy, we can have a lot of data freely available and very soon. But it's not me that can ask.
Yes, probably we cannot provide you a complete answer. What I can say is that official monitoring, mainly with reference to marine strategy, is planned at the start of the monitoring cycle. So I think it will be helpful. Yes, I think it will be helpful to have such additional data, but it is something that must be addressed while planning the monitoring campaign, and we are not the people doing this. So anyway, this is the monitoring campaigns provide official data, and hence citizen science may be helpful only if with a specific role within this institutional framework. So it is something that must be taken with careful and within the framework of the planning of the monitoring. Anyway, we are not the people that can give you a precise answer to this.
But think at that.
Okay, I think we are at the end of the workshop, so I'd like Arianna and Roberta to join me for saying goodbye to all the people participating in this workshop. So Arianna, do you want to close the workshop?
Thank you, Antonello. I want to thank you all the relators, all the audience, all the speakers, and we hope that we will meet again in the next future to speak about our improvement of our results and speak about of what we will do in the next future. So is an arrivederci. We will see very soon.
Yes, I wish to thank Roberta De Angelis for organizing the meeting and all the people from ISPRA that help us in organizing the meeting. So thank you, Sabrina and Attilio, and all the other people that work with you.
Thank you to all.
Thank you. Thank you very much.
Arrivederci.
Grazie mille.
Goodbye.
Stay connected.
Thank you.
Bye-bye, and thank you.